Welcome to lesson 108. Today we're going to be talking about square roots and radical equations, which are simply equations with square roots in them. So let's begin by talking about square roots and reviewing what we already know. So let's say I have the number 9. And then I take that 9 and I square root it. What's the simplification for this? What does this simplify to? You should already know the answer. The answer is 3. Right? And if I were to ask you why, you might say because if I take a 3 and then I square that 3, I get the 9, which is the number inside the radical sign here, the square root sign. All right? That's how we work with square roots. When we talk about the square root of 9, we're simply asking what number multiplied by itself will give me this 9, the number inside the square root. And the answer here is clearly 3. All right? So the thing to note here is that the square root and the square procedure are kind of opposites of each other, much the same way that adding and subtraction or multiplication and division are opposites of each other. To do the opposite of a square root, you're going to square it. If you do the opposite of a square, you're going to square root it. All right? Think about how this is laid out. We started with a 9. We square rooted the 9 to get a 3. But then to undo that, we start with the 3 over here, and then we square that 3. We do the opposite of the square root, which is to square it, and we ended up with a 9. So we started with the 9, and then we ended with the 9 by simply square rooting and then squaring that answer to get us back to the 9. So the point here is that square roots and squares are, in a sense, opposites of each other. Remember that because we'll be working with that when we talk about radical equations coming up in the lesson. Now, if we get back to what we already know about square roots, I might argue that this 3, which was the simplification of square root of 9, might not be the only simplification. So if this is true, that we're looking for some number that we would multiply by itself to get us the 9, it's true that we could take 3 and square it and get to the 9. So therefore, 3 is a solution. But I could also take a negative 3, square that, and that would also give me a 9. So do you see how, in fact, you could make the argument that the square root of 9 might have two different solutions? The square root of 9 might in fact equal a 3 because 3 times 3 is 9, but it could also equal a negative 3 because a negative 3 times a negative 3 is also a 9. So this kind of proposes a problem. Which solution is the one that we want? Well, I think we've talked about this before, but in algebra, when we use this square root sign, we are always assuming that the solution that we want is the positive solution. So when we just see the square root, we can ignore this negative solution and say that our solution is, in fact, just a 3. All right? So keep that in mind. All right? Very good. So now let's move on, and we'll just kind of formally define what the square root is, and then also talk a little bit more about how we can use this. So the definition of a square root, formally, if x is greater than 0, then the square root of x is the unique positive real number such that the square root of x squared is going to equal x. All right, now over on the right here, I just wrote this in just to make sure you understand it. We will assume the correct solution for the root is the positive one. That's what we just talked about. We're only going to select the positive solution. The other thing to note here is that the x, which is the number inside the square root, has to be greater than 0. So we can never have the square root of a negative 2, for example. This will not work. All right? Why won't it work? At least with the tools that we have so far, learned in algebra. If I have the square root of negative 2, what number times itself is going to give me a negative 2? Well, there isn't any. Right? And why isn't there any? Because, and let's maybe just make it more clear. Let's say, what if I have the square root of a negative 4, for example? What number times itself would give us a negative 4? There isn't any. Because if I have a 2, that might be the temptation to say that 2 is the answer, but 2 times 2 itself does not equal negative 4. It equals positive 4. And you might say, well, then what if I do a negative 2 and a negative 2? Well, that doesn't help either because negative 2 times a negative 2 is a positive 4, not a negative 4. And I can't say negative 2 and a positive 2 because then they're not the same number. And the square root means we need the same number multiplied by itself. All right? So clearly when we have a negative in the radicand here, we cannot have a solution. All right? Now watch out because that doesn't mean we can't have negative signs within an expression. So I could do something like this, 6 minus 2. This expression is valid. The square root of 6 minus 2 can be simplified to the square root of 4, which can be simplified to a 2. So this does have a negative sign in it, but the value of this expression is still positive. 6 minus 2 is still a positive 4, so that's acceptable. All right? So let's just get that, make sure that's clear in your head. Now let's take a little bit of a closer look at this definition. What is it saying? Well, it's saying that if you have the square root of some number and then you square it, you're going to get that some number. All right? So let's just put some numbers into this and hopefully it'll be a little bit more clear to you. If I have, like we had before, the square root of 9, all right? And then I take that square root of 9 and I square it. What do I end up with? The answer is 9, right? Because this 9, we're taking the square root of it, and the square root of 9 is 3. And then we're taking that 3 and we're squaring it. So 3 times 3 is 9. So our solution here is 9. So again, we're kind of doing an undoing process here. We start with a 9, we square root it, and then we undo that square root by squaring it to get us back to the original number. So the key thing to note here is that if I have the square root of anything, you pick your favorite number or even a variable. I could even have, a square, or let's just throw an a in there, I guess. If I have the square root of a and then I square it, the answer is going to be whatever's in here. It's whatever's in that radical. So it's going to be an a. I took the a, square rooted it, which gave me something, and then I took that something and I squared it, which by default, by definition, should give us back to, or get us back to, the a. All right? So we can apply this to expressions as well. So if I have the square root of x plus 1, and then I take that square root and I square it, what's my solution going to be? Again, it's going to be whatever's underneath the square root sign. It's going to be x plus 1. All right? So this makes things kind of nice. Anytime you have something that's written as a square root, if we square it, we'll get rid of the square root. All right? And it's a very easy solution. So let's try one more. What if we have the square root of ABC squared over XYZ squared? Something kind of nasty like that. If I take this expression and then I square that whole expression, what do I end up with? Again, I'm going to end up with everything inside the square root sign, which in this case is this ugly fraction. But I don't have the square root anymore. The square root, in a sense, kind of disappears. We're just left with the ABC squared over XYZ squared. Notice the square root is gone. All right? And that is exactly what this definition is telling us up here. Now, how can we use all of these things that we've learned about square roots? Well, let's talk about radical equations. Before we get into this too far, though, I'm just going to back up a little bit and let's talk about this equation. X is equal to 3. All right? Very, very simple equation. X is equal to 3. Now, if we follow our rules for equations, which say that, what we do to one side, we have to do to the other. And up to this point, we've always said pretty much anything you do to the one side is fine, so long as you do it to the other side, it's not going to affect the solution. So if that's the case, let's just say I want to take this left-hand side, and maybe I'll change color here. Let's say we take that left-hand side, and we're going to square it. So we're just going to take this, and we're just going to say, I'm going to square it. Well, if we do it to this side, then we have to do it to this side, right? Okay, so now let's simplify this. We end up with x squared on the left, and then on the right we have 9. Okay, now looking at this equation, x squared equals 9, maybe just in your head, could you figure out the solution? So what numbers could we plug in for x so that this becomes a true equation? Can't plug in a 5, right? If I plug in a 5, I'd have 5 squared, which is 25, and 25 doesn't equal 9. So what squared equals 9? You might say, oh, well, 3 does. 3 does. All right, so let's plug that in. 3 squared equals 9. That is true. That's one way to think of it. But what else could I plug in so that when it's squared, it equals 9? If you think about it enough, you'll recognize that I could plug in a -3, because if I plug in a -3 and then square it, that would give me 9 as well. So both of these would give me 9. So I have a solution of a 3, but then I also have a solution of a -3. So this equation right here, this one right here, has two solutions. It has the +3 and it has the -3. All right? However, going back to our original equation, which was the one in yellow here, maybe I'll rewrite that without our notation around it. The x equals 3. All right, that's what we started with. If I take that x equals 3 and plug in these solutions down here, does it actually work? So let's say instead of this x, we have the first solution, which is this, a 3. So we have 3 is equal to 3. Well, that makes sense. That checks. Now let's do the next solution, the -3. So we plug the -3 in for this x, and we end up with a -3 equals the rest of the equation, 3. -3 does not equal -3. This is a false equation. It's not true. So even though we had two solutions to this equation, which came from our original equation, these same two solutions do not both work for our original equation. All right? So this kind of puts us in a little bit of a bind. Whenever we're dealing with equations and we square both sides, we have to be very careful, because we can often end up with solutions that, although are solutions to kind of, a part or a form of the original equation, they're not solutions to the original equation itself. They could be, but they also might not be. So we have to be very careful when we go about this, when we start squaring things in our equations. So we've always said, whatever you do to one side, go ahead and do it, but just make sure you do it to the other side. That still holds out to be true. One exception to that is that if you square both sides, watch out, because in the end, you're going to end up with two solutions, and they may not both be correct. So whenever you square something while solving an equation, you always have to take that final step and check it with the original equation. So check those solutions as we did here, and you'll find that perhaps one of them does not work and you cannot use it. So in which case, the solution is not 3 -3, it is only 3. All right? So hopefully that kind of makes sense. Let's try a couple examples on this, and I think you'll see it more as we go. So let's try this one. Here we have a pretty basic equation, and we're going to have to solve it. So the first step, very similar to when we solved equations for variables all by themselves, is to first get the radical, or the square root, all by itself. We want to isolate it. Isolate it on one side. So to do that, we're going to move the +5 to the other side. So we're going to subtract 5 from both sides, right? And if we subtract 5 from both sides, we end up with x minus 3 under the square root is equal to a -5. Now, the question is, how can I solve for x? This x is inside a square root. How do we get it out of the square root? Well, this goes back to what we discussed earlier. If we are square rooting something, how can we get rid of the square root? How can we undo the square root? Well, remember we said to undo a square root, we simply square it. So we're going to square this side to get rid of the square root, but that means we have to square the right-hand side as well. And in so doing, this becomes simply whatever's underneath the square root sign again, which in this case is x minus 3. And on the right-hand side, we say a negative 5 squared is going to be a 25, right? Now we keep going. Now it's very easy. We're back to very simple equation work here. So we add the 3 to both sides, and we end up with x equals 28, right? Now, like I said earlier, though, we have to remember, because we employed this square procedure here, we squared both sides, we have to remember that this may not be an accurate answer. You have to go back and check to see if this is a correct answer for the original equation up here. So to do that, maybe we'll change colors here again. Let's go back and plug it in. So we have the square root. Now, instead of an x, we're going to go with the 28. So we have the square root of 28 minus 3 plus 5 equals 0. Just plugging it into our original equation. 28 minus 3 is 25 plus 5 equals 0. The square root of 25 is 5, and then 5 plus 5 is 10. Does 10 equal 0? No, 10 is very different from 0. They do not equal each other. So this is not a true equation, which means that this x equals 28 is not a solution. In fact, there is no solution to this equation. We just eliminated the only one we found. So our answer is going to be no solution. Okay? Otherwise, sometimes people will write, the null set or the empty set or no solution. They all mean the same thing. There is not a solution to this equation. And actually, it should kind of make sense to you by looking at this, because when we moved this positive 5 over to the other side, look at what we got. We had x minus 3 equals a negative 5. Now think about that. We're taking a square root of some expression, some number. We're taking the square root of some number, and then we're saying that some number is equal to a negative 5. So we're saying, in fact, that we have a square root of something, and the square root of that something was a negative 5. But we've already talked about this. We never use the negative solution. Whenever we use the square root sign, the solution is always positive. And here we're saying that it actually has to be a negative solution, which cannot be. So right away, if you ever have the square root of something, it doesn't matter what's in here, the square root of something, and then that equals a negative 5 or a negative number, any negative number, right away you know there is no solution. All right? Now be careful now. Think carefully about what I just said. I did not say if you have the square root of some number and maybe you have, minus 3 over here and then equals some negative number. This is not isolated yet, okay? So what I said is only in regard to when you have it in this form. When you have the square root all by itself on the one side, and that's equal to a negative 5. That's when you can say there's no solution. If you have a square root, and then you have something else, and then that equals something else, you can't say that there's no solution yet. You have to get the square root all by itself first. Okay? All right. So let's try another one. Why don't you pause the video on this one, try it on your own, and then we'll try it together. All right, so we have our equation. Let's first isolate the root of the equation. So we're going to have the x minus 2, and then we're going to move this negative 5 over to the other side, which is going to give us a positive 5 on the opposite side. Now we need to get rid of the square root. And how do we do that? We do it by squaring it. Keeping in mind that this might pose problems, we're going to have to check our answer in the end. So if we square this, we end up with x minus 2 on the left, 25 on the right. We we add the 2 to both sides, and we end up with x is equal to 27. Okay, now we're not done though. We have to plug that 27 into this first equation and make sure it actually works. So we have the square root of an x, which we're saying is hopefully 27. 27 minus 2, and then minus 5 equals 0. So 27 minus 2 is 25. So we have the square root of 25 minus 5 equals 0. Square root of 25 is 5. We're taking the positive answer again. 5 minus 5 equals 0. And this, in fact, does work into a true equation. So now that we've done the check, we can say our solution is x equals 27. All right? Very good. All right, let's try this one. Go ahead and try this one on your own, and then we'll do it together. All right, so how did you do? This one's a little tricky. Let's try it out. So to begin with, we're going to isolate the radical. So we have the x squared plus 9, and we're going to move this negative 5 over to the other side, turning it into a positive 5. Now we're going to get rid of the square root, just like we've done in the past, by squaring both sides. When we do that, we're going to end up with the x squared plus 9 on the left, and on the right, we're going to have 25. Now is where it gets a little bit dicey. So here we have an x, our variable, but it's being squared. So that might make things a little bit more complicated. How do we solve for an x when it's been squared? There are several ways to do this. Now, the way that they suggest in the book is probably the way that we're going to do it this time. Later on, you'll learn perhaps other ways to do this. But right now, what we're going to do is set this thing to 0. All right, so we're going to move everything over to one side and have the right side be equal to 0. So we'll have our x squared plus 9, nothing changes there. But now we're moving this 25 over to the other side. So to do that, we're going to subtract 25 from both sides. And that's going to make the right side equal to 0. All right. Once we have it in this form, where we have the x with its squared component there, and the rest of the expression, and all of that's equal to 0, we can simplify this, and then we're going to factor it. All right, so we'll have x squared, now plus 9 minus 25 is just going to be minus 16 equals 0. Now, what can I do to factor this, right? Well, we've done this before. We can factor this into or a binomial, right? So we have our x as the first variable, our first term in both of these parentheses, these factors. And this is a 16, it's a perfect square. So we have a 4 on both of these. The negative indicates that one's a negative and one's a positive. And there we go. We've just factored this expression. And if you don't believe me, we can go back and check this in our heads. X times x is x squared. Minus 4 times a positive 4 is a negative 16. Negative 4x and a positive 4x would cancel out and give 0. So yes, we end up with x squared minus 16 if we were to remultiply this. All right. So now that we have it in this form, now we can use the zero factor theorem to determine what the x is. And remember, all the zero factor theorem is saying is that when we have everything's being, we have two factors being multiplied by each other, and the answer to that product, or the product of that multiplication, is 0, then in fact, either this one has to be 0 or this one has to be the 0. The first factor has to be 0, the second factor has to be 0, or they could both be 0. All right. So if one of them for sure has to be 0, well, then we can take this x minus 4 and say, well, how could x minus 4 be equal to 0? Well, let's just solve for x. X would have to be equal to a 4. And if x is a 4, then this factor would be 0, which means it doesn't matter what this side is, because 0 times whatever that is going to, in fact, give us 0, which is what it needs to be in order to be a solution. So 4 is a solution. Now we could take this next set of parentheses here, this x plus 4, and say, okay, what if that were the 0 factor? So how could that be equal to 0? Well, that could be equal to 0 if x is equal to a negative 4. Again, if negative 4, we plug that in for x. Negative 4 plus 4, that's going to be 0. And then 0 times whatever's over here, doesn't matter, is going to give us 0, which is what we want. So another solution would be a negative 4. So we have two solutions. We have 4 and negative 4. Now remember, we are not done yet because we employed the squared procedure up here. We squared it. And whenever we do that, we need to remember at the end to check because the answers may not be correct. So let's take these two solutions, these two possible solutions, and we'll plug them into the original equation and just see if one of them works or maybe both of them work. So we'll start with the 4. So if we write the original equation, instead of an x, we're going to put a 4. 4 squared plus 9, and then minus 5 equals 0. What do we get? 4 squared is 16. 16 plus 9 is 25. The square root of 25 is 5. So we have 5 there, minus 5 equals 0. That actually checks out, right? So that means 4 is a solution. This checks. Okay, now let's try the negative 4. So if we plug in the negative 4, we have a negative 4 squared, notice my parentheses there, plus 9 minus 5 equals 0. And negative 4 squared is a positive 16. 16 plus 9 is 25. The square root of 25 is 5, and we're right back to where we were. 5 minus 5 equals 0, and 0 does equal 0. So here, the negative 4 also works. So these two numbers are going to be the solution to our equation. So here, we do have two solutions. They both work. All right? Very good. All right, so let's try one last problem and then we'll be done. So this one, we'll do it together. So to begin with, we will isolate the square root. So we have x minus 1 on the left-hand side. Moving everything over to the right, we'll have a negative 3 turning into a positive 3. The positive x becomes a negative x, and we have this. Now we can get rid of the radical sign, as we've done in the past here. We'll square it, which means then we have to square this side, keeping in mind that we'll need to check our answer at the end. Now we have an x minus 1 on the left equals a 3 minus x squared. Now, to simplify that, actually, I'll just back that up. To simplify that, we'll have to use a FOIL method, or you might be able to do this in your head at this point. But let's just go ahead and do it over here so that everybody can see it. We have 3 minus x being multiplied by 3 minus x, right? And we'll use our FOIL. So the first 3 times 3 is 9. The outside is negative 3x. The inside is a negative 3x. Then the last is a positive x squared. We can simplify this by saying x squared is x squared, and then combining the negative 3x with the negative 3x gives us a negative 6x plus 9 at the end. So we have x squared minus 6x plus 9. All right, so we can see that this one's pretty complicated. We have a variable that's been squared. We've got other variables scattered throughout this equation. So, we got rid of the radical sign, which is great, but it still looks pretty messy. So what are we going to do here? Well, the easiest way to approach this, at least at this point, is to isolate everything onto one side. So in other words, move everything onto one side so that we can use our zero theorem here and do some factoring to solve this out. So I want to keep this x squared positive. I think it's easier. So we're going to move this x and negative 1 over to the right-hand side. And that would just give us 0 on the left-hand side. So moving this x over, maybe I'll just rewrite what's already on the right side here first. So if I move this x over to the other side, it becomes a negative x. Move the negative 1 to the other side, it becomes a positive 1. So again, all I've done is moved the x and the negative 1 to the right-hand side of the equation, and now I have 0 on the left, and then everything else is on the right. And now once that's set up, we can do some simplifications here. So x squared doesn't have any like terms. However, negative 6x is a like term with negative x, so that gives us a negative 7x. And then a positive 9 is a like term with a positive 1, so we end up with plus 10. All right, so now at this point, we can go ahead and factor this right-hand side of the equation. So to factor it, we're going to set up our binomials here. And what's going to be the first term? We're going to have the x squared. That's going to become an x in both of these. Remember our different clues that we use here. The plus sign indicates that the signs are going to be the same, and they're going to be a negative sign, so we'll have two negatives. And then we're going to have something that'll add up to be 7 and is also factors of 10, so that's going to be 5 and 2. So we'll put 5 here, 2 here. All right, and then if we wanted to, we could check this out in our heads just to make sure we do get back to the original expression. X times x is x squared, negative 5x, negative 2x on the outside would give us the negative 7x in the middle, and then the negative 5 times the negative 2 would give us a positive 10. So indeed, it does work out. And now once we've reached this point, you can see that we could use our zero quotient theorem because this product has to be equal to 0, which means that either the x minus 5 is going to be 0, or the x minus 2 is going to be 0, or both are going to be 0. So how could x minus 5 be equal to 0? Well, that would only happen if x is equal to 5. And how could x minus 2 be equal to 0? Only if x is equal to 2. So these two here are our possible solutions. So x could be either a 2 or a 5. Okay? Now, we have to remember that we did do a square move up. Whoops, not right there. We did it up above that. We did this square move here to get rid of the radical, the square root. So we need to check these answers. So let's plug these answers in. We'll start with the 2. Going back to our original equation, we have the square root of 2 in this case, minus 1, minus 3 plus our 2 again, equals 0. And if we simplify this out, we have 2 minus 1, which is 1. So the square root of 1 minus 3 plus 2, well, that can be simplified to a negative 1 equals 0. Square root of 1 is 1 minus 1. It does, in fact, equal 0. So therefore, this 2 is a correct solution. So we know 2 works. What about 5, though? Let's plug him in. So we have now 5 minus 1 minus 3 plus 5 equals 0. 5 minus 1 is going to give us 4. Then we have a negative 3 plus 5 is going to be a positive 2 equals 0. Square root of 4 is 2 plus 2 does not equal 0. So therefore, the 5 does not work. So the only solution then is going to be the 2. So x has to equal 2. All right? So hopefully that makes sense to everybody. Again, it's not very complicated. It's just you have to remember that once you square something in an equation, you're going to have to double check your answers at the end to see if they actually work. And then also just bear in mind that when we have these different equations, sometimes a handy tool is that zero quotient theorem, where if you can factor the one side out and have the other side equal to 0, you can then set each individual factor to 0 to figure out the possible x solutions. All right. Well, we'll stop it here. Good luck on your seat work, and I will see you in the next lesson.